Alright, activity 4.2, question 2. They said by first principle, please no noise class. By first principle, find the derivative of f of x. By first principle, find the derivative of f of x. We are in activity 4.2, question 2. Find the derivative of f of x equals 3x squared plus 2x plus 1. By first principle. Class, we still have the formula on the board. Lim dy dx as dx tends to 0 is equal to lim, please no noise, is equal to lim f of x plus dx minus f of x all over dx. All over what? Class, when they ask to find differentiate by first principle, you will first find f of x plus dx. We are first going to look for f of x plus, this is already f of x, right? F of x is 3x squared plus 2x plus 1. Now let us go and find f of x plus, so that we will now say whatever we get here minus what we get here all over d. Because the formula says f of x plus dx minus f of divided by d as dx tends to, what is f of x plus dx? Anywhere you see x, add dx to it, right? That will be 3 instead of 3x squared, be 3 into bracket x plus dx. Or, so instead of 3x squared, x plus dx, then c squared. Plus 2 into bracket x plus 1. Class, there's no x plus dx, there's no dx with 1, but 1 was not having x in the first place. You're only going to add dx to people that are having what? X. To those people having x, you add dx to them. Class, expanding this bracket, this is a similar, x plus dx square has been expanded several times now, right? You should get to a point where you are faster, where you say x plus dx whole square means x squared plus 2x dx plus dx, or plus 2 into bracket x plus dx plus, class, this will now give us, using 3 to open the bracket, 3 times x squared is 3x, 3 times 2x dx, 6x, 3 times dx squared, 3 dx, or plus, let's use 2 to open this bracket, 2 times x, 2 times dx, 2 dx plus, class, this is clearly f of x plus dx. This f of x plus what? And we have f of x. Let's apply it in the formula now. F of x plus dx is 3x squared plus, let's collect like terms. Anybody that does not have dx first, plus 2x plus 1. Now let's go to this would have dx now. Plus 6x dx plus 3 dx, or plus 2 dx plus 2 minus f of x. Who is f of x plus? 3x squared plus 2x plus, now what that means is that 3x squared plus 2x plus 1, we cancel everybody here. All over, this is what is left now, right? You see why it's good to collect like this, so we can have them in one place. All over dx, right? All over dx means dx will kill at least one dx up in each case. And who survive? 6x plus 3 dx plus, as dx tends to, dx tends to 0 means anywhere we see dx, we put, this will be 6x plus 3 dx plus 3 into bracket 0, dx is 0, right? Plus 2, 6x, 3 times 0 is 0, plus 6x plus 0 plus 2 is 6x plus, and this is the final answer. Now moving forward, activity 4.2 still has I and II. At least let's take I and II, and then we know we have done a good job here for now. I and II for activity 4.2. Class, then I say use the result. Use the what? Result. This one is simple. To find the value of y prime. Y prime means differentiation of y. Y prime means differentiation of y. Undername for y prime is dy dx. What? Undername for y prime. This prime, this symbol here is prime. Y prime means dy. Find the value of y prime means find the value of dy dx at x equals to 2. Class, what is dy dx? 6x plus 2, right? So at x equals to 2, anyway you see x, you put 2, 6 into bracket, 2 plus 6 times 2 is 12, 12 plus 2 is what? 14. Class, this is the answer to I of activity 4.2. I, please no noise. I, x not equals to 1 over 2, right? Class, dy dx at equals to what? 6x plus. So at 1 over 2, it means anyway you see x, put 1 over 2. We're going to have 6 into bracket 1 over 2 plus 2. 6 into bracket 1 over 2 is 3, clearly. Because 2 here 1, 2 here 3. 3 times 1 is 3. 3 plus, and our answer here is 5. So our answer I is 5. I, x not equals 0. I, x not equals, remember again, y prime is the y dx, right? And the y dx we got, they said from the value we got here, 6x plus 2. We got 6x plus what? So 6x plus 2. Now anyway you see x, you're supposed to put 0. So at x not equals 0, we are going to have 6 into bracket 0 plus 6 times 0 is 0. 0 plus 2 is what? 2. And that's that for activity 4.2. Now the next question, activity 4.3, says we should find the first derivative of the following functions without necessarily using the first principle. Class, there's what we call first derivative, second derivative, third derivative. There's what we call higher derivatives in differentiation. There's what we call higher. If someone says you find the first derivative of a function, it means differentiate just once. If someone says you find the second derivative of a function, differentiate twice. Differentiate once, then differentiate again. So for activity 4.3, activity 4.3 is asking us to find the first derivative of the following function without necessarily using the first. So you don't need to use the first what? Principle. You don't need to use the first. You're still writing? Let's do it here. Activity 4.3. Activity 4.3. I said 1 all over x raised to power 3. Now without using first principle, 1 over x raised to power 3 can be sent in as x raised to power minus 3. When x raised to power 3 comes up, it takes a minus sign. So therefore, dy dx, and class x raised to power minus 3 is sent as 1 whole number x raised to power minus 3. 1 x raised to power minus 3. Now when differentiating, remember, multiply your quotient and your power. 1 times minus 3 is minus. Repeat your base x and subtract 1 from the power minus 3 minus 1. This will give you minus 3x raised to power minus 4. Plus this is the derivative of 1 over x raised to power 3. Minus 3x raised to power minus 4. That is for activity 4.3 activity 4.3 I. So we should differentiate x raised to power 1 over 3. If I differentiate this, the y dx will give you 1 over 3 because there's an invisible 1 here, right? So 1 times 1 over 3 is 1 over 3, x raised to power 1 over 3 minus 1. Don't forget there are 3 steps in differentiating normally. If you're differentiating basic differentiation, step 1 is multiply the coefficient and the power. Step 2 is to repeat the base. Step 3 is subtract 1 from the power. And that's what we're doing here. 1 over 3 minus 1. Let's go and find out what is it. 1 over 3 minus 1 over 1. LCM is 3. 3 and 3 is 3. Is 1. 3 and 1 is 3. 1 minus 3 is minus 2 over 3. So 1 over 3 minus 1 is minus 2 over 3. So we have 1 over 3x raised to power minus 2 over 3. Same thing as 1 over 3 x raised to power 2 over 3. Class, when x raised to power minus 2 over 3 comes down, it becomes x raised to power 2 over 3. And class, I can write in short form 1 over 3 cube root of x all squared. Class, this is the derivative of this function. 1 over 3 cube root of x all squared. That's I. Now, I, by now, if you don't write this part, I won't forgive you for this again. If you don't write in this part. This workbook, if you don't estimate like this, this second week now, third week, we are doing workbook. We have not been learning, just workbook. Class, I. After this workbook, it's still important that we prepare for exam. Class, this workbook is a theory, so it can be very deceiving. OBJ exam, if you check your past questions, some of these questions cannot come out in OBJ exam. Do you understand? Objective exam, this way when you are writing a theory exam, when you are sitting objective exam, there are two different things. So we still need to prepare you for exam. So we still need to be learning normally for exam. An exam is 70 marks. All these 32 pages is just 30 marks. I wonder how many marks each question will get. If the whole workbook is 30 marks and I did 32 pages. So solving is 0.5 marks. Some of these things we are solving, you are fighting for just 0.2 marks. Before you can gather 20, you will not solve tire like you will have solved. Because imagine you listen if you're a lecturer, how do you want to mark over 30? All these plenty questions, over 30. Reason it now. Class, square root of x raised to power 3 in indices form, it is written as x raised to power 3 over 2. 3 over square root of x raised to power 3 is written as x raised to power 3 over 2. Now let's differentiate x raised to power 3 over 2. This is the same thing as 1x raised to power 3 over. Differentiating this is 1 times 3 over 2. As usual, multiply the coefficient and the power. 1 times 3 over 2 is 3 over 2. Repeat your base x. Subtract 1 from the power. 3 over 2 minus 1 will give me 1 over 2. But let me show it first. 3 over 2 minus 1. Let's go and show you 3 over 2 minus 1. How do I have 1 over 2? LCM is 2. 2 in 2 is 1. 1 times 3 is 3. Minus 2 in 1 is 2. 2 times 1 is 2. 3 minus 2 is 1 all over. So this will give me 3 over 2x raised to power 1 over 2. 3 over 2x raised to power 1 over 2, which is the same thing as 3 root x over 2. Because x raised to power 1 over 2 is same thing as root x. Same thing as root. And this is the y there. This is the y. Remember, they didn't say we should say not necessarily using first. So you don't need to use first principle. But you can still use first principle if you want. But class, don't use first principle because that space is too small. Normally, that space is too. For just 0.2 marks, you're stressing yourself. Main exam is still 70 marks. 1 over root x. Class, on that good news, it's very hard for them to ask you to differentiate by first principle in the exam. Because whether it's, you use first principle or not, your exam is OBJ, they won't even know. It's just to get the final. So even if they say differentiate by first principle in your exam, still differentiate the way you know normally and get your answer and move forward. Don't try to prove anybody that you can do first principle. There's no time. 1 over root x is the same thing as 1 over x raised to power 1 over 2. Now the square root of any variable is that variable raised to power 1 over. Now x raised to power 1 over 2 can come up and become x raised to power minus 1 over. When x raised to power 1 over 2 comes up, it acquires a negative sign, right? Now let's try to differentiate, and it can be an invisible one there. 1 times minus 1 over 2 is minus 1 over 2. Repeat your x. Minus 1 over 2 minus 1 is minus 3 over 2. You can confirm that. Me, I'm good in fractions. I know that that's the answer. Minus 1 over 2 minus 1 over 1. Let's show you. That's same is 2 in 2, 1. 1 times minus 1 minus 2 in 1, 2 times 1. Minus 1 minus 2 is minus 3 over. So I will say minus 1 over 2 minus 1. Look, I'm showing my working. Look, I'm showing working. You now say minus 1 over 2. X raised to power minus 3 over. X raised to power minus 3 over 2 can come down and become minus 1 over 2 x raised to power 3 over 2. They will no longer be minus, right? Same thing as minus 1 all over 2 root x raised to power 3. Final answer, the y dx for this. Class, activity 4.3, continuation. Question 2. Said we should, using the appropriate formula, determine the derivatives of the following. Using the appropriate formula, determine the derivatives of the following. Using the appropriate formula, determine the derivative of the following. Which one is which one? I've done this one now. This one is the one that is here now. Look at it. I at x equals to 2. I x equals 1 over 2. Check your manual. This one, I saw this one here. I cleaned it now. Check your, ask your. Which one? At 4.2 I. At 4.2 3. I've seen it. I solved it though. Yes. At 4.2 I. Let's quickly do it. That one of first principle, right? Let's quickly do it. Where can I claim? This side. Class, please follow me. At 4.2 I, we skipped it, we didn't solve it. Please let's solve it. So we are back to the first principle again. F of x equals to this at 4.2 I. Please take note. Sorry for going back. F of x equals to x squared. That's I. F of x equals to x squared plus 3x plus 2. Don't forget the formula for first principle differentiation. Lim dy dx as dx tends to 0 is equal to f of x plus dx minus f of x all over d as dx tends to 0, of course, as dx tends to 0. Class, we already have f of x. Let's go and find f of x plus dx. F of x plus dx must be equal to, anyway you see x, put x plus dx, that will be x plus dx all squared plus 3 into bracket x plus dx plus 2. But if I did solve it, you can do it, right? If you have been following. X plus dx all squared will give you what? X squared plus 2x dx plus dx all squared plus 3 times x is 3x plus 3 dx plus 2. Plus what? 2. This will give us x squared. Collect like terms plus 3x plus 2 plus 2x dx plus dx all squared plus 3. Class, this is f of x plus dx. Now put it into the formula now. But we are going to find f of x plus dx minus f of x. So that will be x squared plus 3x plus 2 plus 2x dx, please no noise, plus dx all squared plus 3 dx, please no noise, minus, who is f of x? X squared plus 3x plus 2 all over the, this f of x plus dx minus f of, class, this x squared plus 3x plus 2 will cancel x squared plus 3x plus, leaving you with 2x dx plus dx all squared plus 3 dx all over the dx kills dx here. 1 dx goes here, under dx still remains. 1 dx goes here. And you are left with 2x plus dx plus 3. Now as dx tends to 3 or to 0, we'll give you 2x plus 0 plus, giving you 2x plus 3. This is the answer to activity 4.2 I. Activity 4.2 I. So we can now go back to activity 4.3 now. Question 2. Activity 4.3 question. You can see where we did activity 4.3 question 1 here. Look at question 1 questions. Activity 4.3 I, and I. This 4.3 I, and I. 4.3 I. Now, activity 4.3 question 2. We are told that using appropriate formula, determine the derivative of the following. Using appropriate, determine the derivative of the following I. So please, we are in 4.3, activity 4.3. Because some people are now confused. Let me writing what I'm doing. Let me writing so you can trace it in your book. At 4.3, question 2i. So using the appropriate formula. Class, who are the appropriate formula? Product rule, chain rule, quotient. So the question determines the formula. It should say using appropriate for I, x squared plus 3 into brackets 2x squared minus 1. Class, have I taught you product rule in this class? Yes. Chain rule, quotient rule. What rule would we use here? Product. This product. In product rule, you call the first person u, call the second person. When you have product of 2x components, the first person should be u, second person should be. So you say let u be equal to x squared plus 3 and let v be equal to 2x squared minus. Now differentiate u with respect to x, you have du. Remember this thing we did now? And v to x, we have dv. You see? 2x raised to power 5. See, thank you for correcting me. I'm rushing, so it's possible I made little mistakes. 2x raised to power. The question is actually 2x to power. I wrote 2x squared. It's 2x raised to power 5. Now, thank you. Oh, we went far. We're gonna make mistakes. Now, x squared is 2. 3 is 0. It disappears, right? 2x raised to power 5. Differentiate, you have 10x raised to power. Minus 1 is the constant. This you now say, recall from product to from what? Product rule. Because it's using the appropriate rule, the appropriate formula is product rule is the formula I'm going to use. The y, they also remember the formula for product rule. I've given you before. U dv good plus u dv dx plus v du d. Who is u? X squared plus. Who is dv dx? 10x raised to power plus v. Who is v? 2x raised to power 5 minus 1. And who is du dx? 2. Please, if you miss any of this class, maybe you haven't practiced at that time. Remember, we'll still do exam focus. I'll teach it again. Don't worry yourself. I'll teach all these things again. And normally, we'll start. Watch out for exam focus class. Exam focus class will start all topics from the beginning again. And make sure you are ready for exam. It's a marathon exam focus class. We'll start in the next 1 or 2 weeks' time. And we focus towards your exam. Each course will come from the beginning again. We'll start each course from the beginning again. So class, let's expand where necessary. X squared times 10x raised to power 4 is 10x raised to power 6. And 3 times 10x raised to power 4 is what? 30x raised to power plus, let's expand here, 2x times 2x raised to power 5. 6. And 2x times minus 1, minus 2. Class, I've taught those polynomials before. Can any of them add up or multiply each other? Oh sorry, can any of them add or subtract each other? No. Because they have different degrees. Remember, when we did polynomials, you cannot add up numbers of different degrees, right? They are not at the same level. This is x raised to power 6, this x raised to power 4, this x raised to power, okay, this x raised to power 6, x to power 6. Then x raised to power 6 plus 4 x raised to power 6. 14x raised to power plus 30x raised to power 4 minus 2x. Normally, when you are solving math, you should not rush. You will make mistake. You make. So please, if you see me that we have based on it, you just let me know. 10x raised to power 6 plus 4x raised to power, give me 14x raised to power plus 30x raised to power 4 minus 2. This is the dy dx. You can't go further than this, right? Because they don't have the same power. This is the dy dx of this function using the appropriate formula, using the appropriate formula. Class. Question 2ii. Although I'm seeing IV here, but I think it's a mistake. Class, what formula will you use for someone like this? When you have a fractional function, have I not told you the formula to use? What formula we use anytime your function is a fraction? Quotient rule. We use quotient. Anytime you give a function and you have numerator and denominator, class, you must use quotient rule. In the quotient rule, you will call your numerator u and denominator v. Let your numerator be u and let your denominator be v. So say u equals to root x, class, and v equals to 1 minus. Class, it's very important that the person up is u and the person down is v. Please do not make that mistake. Let your numerator be u and let your denominator be. So that if u is root x, don't forget that root x is written as x raised to power 1 over 2. Do you agree? That the square root of any variable is that variable raised to power 1 over 2. And that will give us Differentiating x raised to 1 over 2, we are going to have 1 over 2 x raised to power minus 1 over 2. Same thing as 1 over 2 root x if you do everything very well. And differentiating 1 minus x, differentiating means you are now looking for du dx, right? So du dx, because when you have u, then du dx means differentiate root x, right? You land there. dv dx means differentiate v. Differentiate 1 is 0, minus x is minus 1. So dv dx is minus 1. Now you now say recall quotient rule, right? Who remembers the quotient rule formula? You still remember? Yeah, tell me, let's go. Thank you. V du dx minus good. So if we are reading, that's good. All about what? All about v. Who is v? 1 minus. Who is the u dx? 1 over 2 root x. 1 over 2 root minus u. Who is u? Root x. Class, if you can solve this manner, your exam is simpler than this manner. This manner is harder than your exam. This manner is harder than your. So anybody that can destroy this manner, exam will be chicken change for you. Because you have to show it solving step by step. You have to actually know it. You can't guess. Exam is OBJ, you can just manipulate sometimes. I'll teach you shortcut in mathematics soon. We'll do shortcut class in mathematics. Where some questions, I just punch your calculator. There are some questions that you can differentiate your calculator. Are you aware? You can differentiate, integrate your calculator. We'll get there soon. So u is root x. Now dv dx is minus all over v square. Who is v? 1 minus x. Or 1 minus x times 1 will give us 1 minus x all over 2 root x. Minus root x times minus root x times minus 1 will give us plus root x all over 1 minus x all square. Class. Funny thing about differentiation, like you don't just give your answer like that. You must break it down to the simplest form possible. And that part is not differentiation again, is you knowing mathematics. And normally we are done, we are differentiated, but you cannot present your answer like this. You can still find the LCM in the numerator here. Plus 1 minus x all over 2 root. So please, we are copying this way, follow like this way. Plus root x all over 1. Let's find the LCM. It's 2 root x, right? 2 root x and 2 root x is 1. 1 times 1 minus x plus 2 root x in 1 is 2 root x. 2 root x times root x is 2x. Plus 2 root x times root x. Plus root x times root x is x. Then with this 2. Plus this multiplication of two subs of similar element is the element itself. Root 2 times root 2 is 2. Root 3 times root 3 is root x times root x is x. You can see that we are rushing this thing, so you still have to come for the exam focus class so we can teach it very well for exam. With the assignment now, you know they have postponed several times, Abby. So let us know. You can see after Easter, everybody submit. Do you understand? And again, when they don't say submit, we have wasted too much time on this. We have to learn other things. Integration is still there, other things are still there to learn for exam. So 1 minus x plus 2x all over 2 root x all over 1 minus x or now minus x plus 2x. Minus x plus 2x is plus x, right? So 1 plus x all over 2 root all over 1 minus x or same thing as 1 plus x all over. This thing we are doing now is no more differentiation. It's just simple mathematics simplification of our answer. We have differentiated since. So even if you can differentiate and you're not good in math, still affect you. You need to simplify your answer. 1 plus x all over 2 root x divided by 1 minus x or when you multiply, it will be 1 plus x all over 2 root times 1 all over what? 1 minus x or giving you 1 plus x all over 2 root x into bracket 1 minus x or at this point you can't go further. Final answer. 1 plus x all over 2 root x into bracket 1 minus x all square. What's the time there? 5:49, okay. Let us try and finish at 54.3 and go home. Eh? There are just 2 questions in 4.3 remaining. There are just 2 more questions in at 4.3. So class, next question at 54.3, we have 2x all over 1 plus root x. Class, this is still quotient rule, right? Anytime your function is in a fraction like this is quotient, you call your numerator u and your denominator v. So u equals to 2x. What will be du dx? Du dx is what? 2. V equals to 1 plus root x. What will be the v